Let's take a look at the first example. This time I have w squared and x squared in the first term, and I have also wx in the second term. So I'm going to use the properties of exponents, and I'm going to rewrite wx squared. Instead of w squared x squared, I'm going to write wx squared. It's the same thing. Minus 10. And I'm going to write wx inside of the parentheses times y plus 21y squared. Okay? Now, I'm going to treat this expression as a single variable at this moment. Also, wx is going to be treated as a single variable. Now I have to look at y's. Y in the third term has the exponent which is twice of the exponent of y in the second term. That's why at this moment I can forget about these two y's. I can forget only if the third term has the variable raised to the power which is twice of the power of the same variable in the second term. That's why I'm going to forget at this moment about y's. I'm going to write wx squared minus 10 wx plus 21. My leading coefficient is invisible 1. Okay? That's why I'm going to write the parentheses, and because my leading coefficient is equal 1, the leading coefficient for each binomial is going to be also 1. That's why I'm going to have wx over here and wx. The positive sign next to the third term is telling me that these two signs of the factors are going to be the same. And because I have negative sign next to the second term, my signs are going to be negative. They're supposed to be the same, and because this one is negative, both of them are going to be negative. Next, I have to ask myself what numbers multiply by each other are going to give me 21 and add to each other are going to give me negative 10. These numbers are negative 3 and negative 7. Negative 3 times negative 7 gives me 21. Negative 3 plus negative 7 gives me negative 10. Someone is going to say that this is the end of the problem. Not yet. Remember that we forget at the beginning about two y's. Now, I do not have y next to the first term. Okay? Y is not the part of the first term. That's why I'm not going to write y, okay, in my first terms of my binomials. That's why I'm going to write wx minus 3y times wx minus 7y. Let's check if this is correct answer to our problem. wx times wx is w squared x squared minus wx times negative 7y is minus 7wx y minus 3y times wx is minus 3wx y minus 3y times minus 7y is positive 21y squared. Combine the like terms. W squared x squared minus 7wxy minus 3wxy is minus 10wxy plus 21y squared. As you can see, this is the original trinomial. That's why this is the solution to my problem. Let's take a look at the second example. We have very similar situation. I have x squared, y squared, and I have xy. Again, I'm going to use the properties of exponents. I'm going to rewrite this problem as x, y to the second power plus 2 x, y, z minus 63z squared. Okay? I'm going to treat xy as a one variable. Okay? So I'm going to right now look at z's. Anytime I have variable in the third term raised to the power, which is twice of the power of the variable in the second term, I can forget about these two variables at the moment. That's why I'm going to rewrite this problem as x, y to the second power plus 2 x, y minus 63. Next, we're supposed to factorize this trinomial. Please notice that the leading coefficient is equal 1. That's why the leading coefficients of my binomials are going to be also 1. Now, next I have to look at the sign next to the third term. It's negative. This sign is telling me that both signs are going to be different. So plus, minus. Positive sign next to the second term is telling me that the bigger number is going to be placed next to the positive sign. What numbers multiplied together are going to give me negative 63, and what numbers, the same numbers added together, are going to give me 2. They are 9 and 7. 9 times negative 7 is negative 63. 9 plus negative 7 is equal to 2. Someone can say that this is the end of the problem. Not yet, because at the beginning we forgot about z. We have to bring this z back into our problem, because z doesn't exist in the first term of my trinomial. That's why I'm not going to put z into the first terms of my binomials. So I'm going to write x, y plus 9z times x, y minus 7z. Let's check if this is right answer. xy times xy is x squared y squared. xy times negative 7z is minus 7xyz. 9z times xy is 9xyz. 9z times minus 7z is negative 63z squared. Combine the like terms and you will have x squared y squared plus 2xyz minus 63z squared. As you can see, this is the original expression which we start with. So this is the solution to my problem.